In this topic, we will look at displacement reactions. Displacement reactions mostly happen in solutions, where the more active element, either a metal or a nonmetal, displaces the less active ones. All displacement reactions are endothermic. In order to understand this, let us take a look at the reactivity series of metals. This is an arrangement of metals in order of their decreasing reactivity, with the most reactive metal on the top, and the least reactive metal at the bottom. Sometimes, this is also called the activity series. In the table, we can see that potassium is the most reactive metal, followed by barium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, tin, and lead. Hydrogen is a nonmetal, but can lose an electron to form H+ ions, similar to the behavior exhibited by other metals. Metals lower in reactivity than hydrogen are copper, followed by mercury, silver, gold, and platinum. A few points to call out regarding the reactivity series. Reactivity decreases as we go downward in the table. Metals that are higher in the series can displace other metals that are lower in this series. Metals above hydrogen react with acids to release hydrogen. All the metals can lose electrons, and thus undergo oxidation. Like metals, nonmetals also display varying degrees of reactivity. As an example, the second table shows the relative reactivity of halogens. We see that the most reactive halogen is fluorine, followed by chlorine, bromine and iodine. Thus, halogens higher in the table, say, fluorine, can displace those lower in the table, say, iodine. Having seen the reactivity series, let us look at a few displacement reactions in detail. As mentioned previously, all displacement reactions are endothermic. Displacement reactions in metals. Iron displaces copper from blue aqueous solution of copper sulfate, to form light green ferrous sulfate. Brown deposits of copper are formed on the iron, or at the bottom of the container where the reaction takes place. Zinc displaces copper from blue aqueous solution of copper sulfate, to form colorless zinc sulfate. Here again, brown copper deposits are formed. Magnesium displaces hydrogen from dilute sulfuric acid to form magnesium sulfate, and hydrogen gas is released. Sodium displaces hydrogen from water to form sodium hydroxide, and hydrogen gas is released. Ferric oxide reacts with aluminium to form alumina and iron. This occurs at high temperature, and the process is called aluminothermy, or thermite welding. It is used for joining broken parts of iron machinery. Displacement reactions are used for extraction of precious metals, gold, silver. This is done by dissolving their ore in sodium cyanide solution, and adding granulated zinc particles. In the reaction, the less reactive, gold, silver, are displaced from their respective ores. Let's take an example of nonmetals showing displacement reaction. When chlorine gas is passed through potassium bromide solution, bromine is displaced by potassium. Bromine gets dissolved in the solution, thereby turning it reddish-brown. The other product formed is potassium chloride. To summarize, in this topic, we have learnt what are displacement reactions. We also learned about the reactivity series of metals and halogens, and we saw few examples of displacement reactions in metals and nonmetals.